I'm going to show you the two topology they use in the inverter section. All right, okay, so we are working on this high frequency hybrid inverter. Why do we call this high frequency hybrid? It's because the design is made with a high frequency transformer. That's the first part of it, and the second part is that the MPPT section of it, all right, is sandwiched with the board, meaning in this enclosure that has this board, we have the combination of the inverter board and the MPPT section all together, making it hybrid. Making it what? Hybrid inverter. Now, we are going to look at the two topology that they use in the design of this kind of inverter. First, the primary section here, where you have the MOSFETs. That is the section that relates directly with the battery. Converting of the DC from AC to AC is done through this section. So the section here has the MOSFET, and the MOSFET powers the high frequency transformer. The output of this is going to be a DC or an AC of a very high frequency. The AC that will be generated here is going to be of a very high frequency, which cannot be used. So what will happen is to convert that AC output voltage back to DC. The DC that will be generated at that point will be stored in the reserve section where you have the capacitor. The capacitor here is rated around 400 volts to have the storage capability for the voltage that will be converted from AC here back to the DC. So the storage unit for the battery section is also, you know, on the battery, closer to the battery terminal. So this is the capacitor for the battery reserved. This is the capacitor for the high DC voltage reserved, which is called the power factor correction DC. Now, let's look at the two topology, like I said, that they use in the preparation of converting from the DC to AC in this high frequency design. The first one is the center tap configuration. In the center tap configuration, you will have the MOSFET only controlling the low section, which is the battery, which is the negative section of the battery, being switched. All right, the negative section of the battery is being controlled, switched to power the transformer. Where does the positive of the battery goes? The positive of the battery goes directly to the center tap of the transformer. So here I'm going to, you know, introvert the board for you to see. Okay, so we have, if you look closely, you will see that there are three terminals here. 1, 2, 3. This three terminal is the primary section of the transformer. All right, that is the section that relates with the primary line where you have the battery. So now this two is connected to relate with the low section of the MOSFET. We have the left and the right section from the low side. All right, so the